Today, I want to talk about a new topic called sensors and actuators. During this chapter, we want to be familiar with different types of sensors and actuators that are used in digital systems. In fact, we can say that sensors and actuators are devices that permit the smartphones have interaction with us or let a robot to navigate an environment. And also we can say that they can let devices to communicate over wireless network and so on. That was the task of sensors and actuators in digital system that we will talk about that. Now, before starting to talk about the different types of sensors and actuators, let's define them. What is a sensor? In fact, a sensor is a device that can convert different forms of energies into electrical signals. This is the meaning of sensors. Convert energies into electrical signal. Okay, what about the actuators? What can we say about the actuators? Or how can we define an actuator? We can say that an actuator is a device that converts electrical signals into different forms of energy. What kind of energy? The energy that we can see, hear, or feel it. In fact, we can say that sensors and actuators perform dual role in digital system. Generally, we can divide the sensors and actuators to 5 different groups. The first group is mechanical devices. For example, when you push buttons in keyboards, some switches perform and convert the mechanical energy into electrical signal. Another type of these devices are acoustic devices. Acoustic sensors detect human speech like microphone, and acoustic actuators play audio like speakers. The third one is optical device. Actually, optical sensors perceive the environment through image. Okay, perceive our environment through image like cameras. And optical actuators display video like monitors. Another type of sensors are accelerometers or GPS. GPS is abbreviation of Global Positioning System that are called proprioception. As a matter of fact, the meaning of proprioception is perception or awareness of the position and movement of the body. Okay, but in the case of sensors, we use them to find their location and position and movement of an object. Using GPS and accelerometers, we can actually find the location of an object. Finally, the last type of sensors and actuators are active devices. These devices use optical or acoustic energy to automate tasks. Okay, that was the general information about the different types of sensors and actuators. Now let's learn about them in detail. I will talk about all of these types in detail during this chapter. Analog and digital sensors. Generally, we classify a sensor by the type of signal that it produces. Analog sensors produce waveforms that change continuously in time. As you see here, this is the input of sensor, and this section is output of the sensor. A sensor that produces analog signal called analog sensor, and digital sensors produce discrete values, as you see here. As an example, for analog sensor, we can say, as you see here, mercury thermometer. This thermometer produces an analog signal that varies continuously during time. On the other hand, we have digital thermometer that produce discrete values, as you see here. This value is discrete. But in the mercury thermometer, this value is continuous value. In fact, in practice, a digital sensor is composed of analog sensor that convert the analog value into the digital approximation. Okay? Each digital sensor composed of analog sensor that can convert the analog value into the digital approximation. And here I wrote these sentences. A digital sensor is typically composed of an analog sensor that converts energy into waveform that is followed by a device that converts the analog value into the digital approximation. I will talk about the analog to digital converters. Now we start talking about the mechanical sensors and actuators. The first type of sensors and actuator was mechanical. The simplest sensor that is used in our system are switches. This sensor produces binary outputs, 0 and 1, 0 and 1. We say that if switch is open, the output is 0. And when the switch is closed, then output will be 1. Imagine a switch. When switch is on, it means that, or open, it means that the switch is off. And the value in the output is 0. When the switch is closed, it means that we will have 1. This type of sensor is well suited to digital logic and computer systems. Why they are useful? The computer systems and digital logics used binary system because these switches produce 0 and 1. It means that they are suitable for us to use them as a sensor in digital system. Look at here. In this figure, you can see one of the mechanical switch. and this is the schematic form of this switch, that has 3 terminals. This is called terminals. 1 terminal, 2, 3. 1, 2, 3. This C is contact. This C is contact. NO is normally open contact, and NC is normally closed. In the normal situation, as you see here, the left side of the circuit is connected, and when we push it, the right side is connected, and the value of 0 is changed to 1. In this section, this root is connected, so we will have 1 here and 0 here. At this section, this root is connected, so this is 1 and this section is 0. Okay, another type of switches are called on-off switch, which is used on electrical devices. As you see in the figure, when switch is on, allow current to flow to the device by connecting to the battery. When switch is off, you don't have any current flow from battery to the device. So in this case, you will produce 0, and at this case, you will produce 1. Because the current is flow from your device, and at this section, you don't have any current flowing from battery to the device. These switches are called on-off switches. On-off switches. Okay, switch arrays. What is the switch array? If you look at your keyboard, you can find that each key of computer keyboard is a switch. Each of them are switch. But how does it work? In fact, a keyboard is structured as a two-dimensional array of switches formed by the rows and columns. Your keyboard is a mechanical switch that is structured as a two-dimensional array with rows and columns. As I said before, each computer understands only binary numbers. So computers employ binary addresses to identify switches and identify the address of switch. Now, if we have B bits for addressing each key, it means that we will have 2 power of B unique binary address. For each address, we call most left bit, which is called most significant bit, MSB, the most left bit, and rightmost bit, which is called least significant bit. Least significant bit. MSB and LSB. I will talk about that. Look at here. This is our keyboard. If I press one letter like W, E, S, A, D, F, in below of each key in the keyboard, there is a switch which is represented here. This is switch. Okay, when you press it, this switch is connected like that. Look at here, the D1 is connected. The others are open. Only the D switch is connected, is closed. It means that you push it. You push or press the D key in your keyboard. What happened in this case? Look at here, for each keyboard, we have columns and rows. 0, 1, 2, and this is 3. Doesn't matter. Each element is an alphabet. For example, I don't know. We define a binary address or pattern or binary address for each column and row. What is the address of the zeros column? Zeros column. This is a row, this is a column. Okay, let's talk about the 0, 1, 2, 3, 4. How many bits do we need to produce the 1? Because I know that if I write 1 in the binary system, I can write that 1 times 2 power of 0. It means that 1 times 1, 1. How many bits do we need to produce the 2? 1, 0. These 2 bits, these first two number can be represented with 1 bit. The second 2 can be represented with 2 bits. So if I want to show all of these 4 number, the minimum bits that I need is 2 bits. 2 bits, okay? So what will happen? For 2 and 3, I write 1, 0, 1, 1. And for 0 and 1, I can write like that, 0, 1. Because the left side of the number, always it doesn't matter. We learn that for representing 0 up to 4, we need minimum 3 bits like that. 0, 1, 0, 0, 1, 1, and 1, 0, 0. And for 1, 0, for 1, we need 2 bits. 1, 0. Because I want to only use 0 up to 2. The minimum bit that I need is 2. And here, because I want to write 0 up to 4, because 4 can represent it with 3 bits, it means that For representing 0, 1, 2, and 3, I have to use 3 bits. Now look at here. As you see here, for 4 columns, for each column, we have this binary code. This is the code for the column 0. For 1, this one. For 2, this one. For 3, this one. For 4, this one. What about the row? For representing 0 up to 2, how many minimum bits do we need? 2 bits. For 0, 0, 0, 1, 0, 1, 2, 1, 0. Now, look at here. If I press for example, the D letter, what happened? I connect this pass. Oops. This pass is connected. Is it okay? Because this switch is connect, as you see here, this switch is connect. This pass is connected. Using these routes, this code and address 01 for row and 010. These 2 for row, these 3 bits for column. Generally, 01010 is sent to computer. This is the address. This is the address of this code or this pattern or this address is transmitted to the computer, and computer understand that this number in binary system comes from 01. It means that 01 from first column, first row, and 010, it means that 2 column